What I wanted to talk about today is a little bit about some things that I've seen over time that at first I didn't find very intuitive of how Docker was working and behaving. And at the same time, it's some things that I have not seen often being applied also in projects. So these kind of things tend to be a little bit, overlooked or ignored. So I don't know if there's a conscious decision usually all the time, or it's just maybe not worth it. But anyway, a few things about Docker. I'm basically focusing, by the way, in the building of the image. So I will not touch anything about the actual running of the image. Things like, I don't know, Docker Compose, C groups, resources. I will not touch those. But I will focus on the build process and mainly three main topics there, which is the image size, the Docker cache, and the Docker building context. And then some specifics about the Docker with the Java environment. Let's see. So before going into a small example, practical example, a little bit of theory about Docker. I'm not sure if you know, but Docker internally works with the so-called union file system. And what that means is what you see on the right. So there are multiple layers that compose the actual Docker image. And you have the basic one with basic file system, kernel, and so on. Then you have your base image. And then every command that you add, it represents also a new layer. And it ends with a thin layer of that is actually writable, and is the one on which the application or the image will run. So what this means is that the meaning of the union file system is that it's going to take all these layers and it's going to collapse them, so to say, in a way that every change of every independent layer is going to be at the end altogether is going to be the representation of the file system that the Docker image is going to run on top of. So what I want to show is a small example. Is this big enough? I think it is. So I want to show one second, small example of how to of what the layers look like. And I'm just going to build this for a second. And there is this command, Docker history, that actually shows what I was just talking about the layers. So each line that is displayed in the output of the command is a different layer. And you can see that even the layers from the base image are listed here. And you can also see the size of each independent layer. And we can see that the base image is around 70 megabytes. And this is all consistent in this place. If I check size of the Docker image after being built, again, it's consistent. And if I run the image. It is just doing a simple list showing the size of the file system. It has a little bit of overhead, but it's relatively consistent. So if I do add an instruction, it's going to add an additional layer. And in this case, I'm just creating a file. This is something relatively common in any Docker image. You copy a file over, maybe a jar file, or you download a file from somewhere, or you copy some resources. So it's quite often that you can have a copy or an add command. And in this case, I execute the image again. The file is there. It's a file with 100 megabytes. The total size has increased. It's consistent. And if I check layers, there is an additional layer there with 100 megabytes. All pretty consistent now. Size of the image, again, consistent. But this is the part that surprised me in the past. And it's I'm adding another instruction, which is just changing the permissions of the file. Again, something that could be relatively often used. Maybe you copy a binary file and you want to execute it. You need to add the execution permission, and or it has to be you copied it and it was read-only, and you want to be so that it's writable. So you just change the permissions. And if I run the container, nothing has changed in terms of size. So there's still one file there. The total size on the of the high-level layer on is the same. But if I check the size of the image, now has increased up to 279. And if we check the layers, we see that this simple command that is just changing an attribute of the file, it actually translates into a completely new layer that is copying the same file over. And even more so if I just add another line that, okay, maybe I copied the file over, I did some operations with it, and then I want to remove it because I don't need it in the final image. If I execute the container, it's going to look like there's no file. So file system, when running the container, is just my base image. However, in checking the size of the container, it's still 270 something. And if I check the layers, those two layers where I add the file and modify the file are still there. So the file is not anymore in the final image or in the final representation of the image, but is there as a layer. So this can lead to quite some waste if when creating the Docker file we're not careful about it. So there are multiple ways of avoiding this. The basics is to actually just write down your Docker file in a way that you prevent these kind of things. Then you can also use multi-stage builds, which has other benefits, but this could be a way of also addressing this. And you could also leverage build packs, which again has also other added benefits. But it could also be a way of reducing these kind of things. So the basic is about your Docker file. And basically what you want to do is, if I go back again, I don't know why it's jumping. What you want to do is install only or have a really clear overview of what you need to run your image, your application, or your code. So if you need to install a specific package, you install only that single package. You don't install things that are not necessary, and you also combine commands, and I'm gonna show what I mean with that. You probably have seen this, something like this, or copy paste at some point, something like apt update and apt install, maybe, I don't know, curl, because you need curl, and then yeah, remove some I'm not sure, I think it's leave update. I don't remember the details, but some command like this. And basically what this is doing is you're updating the repository, you are installing your additional package that you require, and then you are also removing everything that has been pulled into the system by the update of the repository. So this is exactly what I mean with combining commands, because if we do something like this, it's going to execute all 3 commands in the same layer. So whenever we run the build, and we show the what happened? I didn't save the file. I build, and then I check. Those layers are not there anymore because there is a single layer. And everything I did, so I copied the file over, created the file, whatever, did some operation on the file, but then at the end I removed it. So this saves all that wasteful layers that were not needed. So this is quite a basic thing to take into account in order to reduce this kind of, especially if you have a complex Docker file that is doing a lot of things. This is the very first thing to take into account. And this was for me quite counterintuitive, again, to understand why. Because the first time that I would see a command like this, my first feeling was like, I don't really like one-liners and doing a lot of multiple things together. It's a little bit harder to read. You might overlook things, but yeah, it has actually a reason of why you see very compact commands, a change of commands in Docker files, and this could be this is probably one of the reasons why it happens. Now, there is another thing, pretty cool thing about when building Docker files, and it's a multi-stage build. And when you first get introduced to Docker, one of the very first things that is described as an advantage and the reason to be is that to have a predictable or a consistent environment in which you run your application. And I say that, yeah, that's what pretty much everybody uses. So it doesn't matter if you run your Docker image in your laptop, in the cloud, on a server, on a VM, it always has the same environment. You have your base image that you define, then your code, whatever you prepare, is there. But you can take it a step further and you say, okay, I want to also have my build environment in a Docker environment. And what the point to take into account is that they are two different environments. The way you build your application, you might have a need of specific SDK, a specific tooling, specific commands that you need available. And the way you execute your final result, you don't need all of that. You need probably a much more small environment. So you can optimize that, and you can combine it with using the multi-stage. And it's actually quite simple how to write a multi-stage Docker file. You pretty much just start as any regular Docker file, but then you add a label, and then you can define multiple stages. And this is just as an example, like, yeah, I'm pulling from a specific base image, creating a file. Then I have a second stage with another different base image, creating a different file. And then I have, for my actual end result, I want to have a very small image, just using Alpine. And then I'm copying over the results of those previous stages into this final stage. And if I execute this, I build it. It takes a little bit for a Maven one, which is a bit heavier. But the end result is going to be that there's not going to be reference to a Maven. There's not going to be reference to a Debian. The final image is just Alpine, and with the results of those previous stages. If I execute the image, is just simple, just listing the content. You see that the two files are there. And you see, if I show the size of the image, it's just a very small image. And if I check layers again, it doesn't have anything referencing the intermediate or the previous stages. So how it could solve the problem that we were talking originally about the size? Well, if you have all these commands and you still want to have them separate, it's not going to matter, because if the final result is just if the final result is that the file is not going to be there, I could just have this labeled as a stage one, and then I could have here my final image, and based on that, yeah, my final environment that is going to be executed. At the same time, depending on how complex is your application or the package that you're building, this can be very powerful. I do remember a case that we were building a Python script, but the script was relying on some dependencies that were not available in package management systems. So we had to actually build those libraries, and we could have just a first stage that would be based. We would have all the tooling for compiling libraries like GCC, dependencies for the driver that we need to build, and all that was just a single stage. And then on our second stage, we had just our Python SDK. We had integrated with the library that was compiled. And our last part was just a very basic Python runtime environment with our end result. So it's actually quite powerful. So it's I think it's a good, nice, a good thing, a nice thing to know about. And the last thing that is also a possible workaround to the thing about layers is the build packs, which is quite, I think it's getting quite some traction in the last couple of years, which is an officially coordinated project by the same parties that are also involved in trying to get this more these cloud environments that are more how you say to prevent vendor locking and these kind of things, so to make it more uniform across all different environments. So it's the same people which is doing that. And it has some advantages. If you have relatively simple Docker files, then you probably don't need them anymore. It can help to reduce security risk, because maybe if you are using an image which it has too many tools or is too open, you can mitigate that. You may even have some performance benefits, because whoever is maintaining these build packs really knows a lot more that the average developer might know about Docker. So they might know tricks, things to speed up builds or the final result. And on top of that, it's also not restricted to Docker even. You can also use other container environments because it's based on the OCI. So the drawback, of course, is that you have less flexibility. If you would have a scenario like I was saying before, that you want to go with the multi-stage because you need to build different technologies together, yeah, might not be the way to go, but for simple things, it might be a really good solution. And that's pretty much about yeah, the size of the containers. Wow, stop. The other two kind of related topics are also part of the Docker builds. Wanted to briefly touch is the build cache and the build context. And for that, I'm gonna use another example here, quite simple as well. So first thing to mention is about I'm going to start with the context first. What's the build context? In case you don't know, the Docker client, which is the one sending the Docker commands, and the Docker daemon, they are two different things. And whenever you are building a new image, the Docker client is going to send the context to the Docker daemon so that it can create your image. The context is relevant because everything that you reference in your Docker file needs to be available in that context. So things like copying over files, maybe from a build, maybe because you need those files, maybe some data, whatever. All that needs to be moved to the Docker daemon, and that's done through the Docker context. And what I misinterpreted when I started working with Docker is that I thought the Docker context was just as simple as a path, which is just, in this case, this is just the dot. It could be a different location. Maybe you have, I don't know, your build Docker file somewhere. something like that, whatever. But what you are actually passing is you are defining the path of what you want to be moved to the context. So in this case, if I just say my context is my current directory, it's actually going to be copying all of this to the context. And what it can happen, and you can see, for instance, here, is that if you have maybe really big files or a lot of files, that's gonna take a considerable amount of time when copying it over to the context. So depending on how you're using Docker, if perhaps you're using Docker as a build environment, if every time you trigger a new build, you have to copy the whole current path into the context, I'm not gonna say you are gonna waste a lot of time. It's not gonna be minutes probably, but it can get easily annoying if every time you need to wait, I don't know, 10, 15 seconds just to copy things and then actually do the build. So, of course, every time, as many things, there is some caching for Docker as well. And it takes into account as well for the context. But whenever I modify the files that are in that context path, it's going to again copy them over. So if you are, for instance, you have, I don't know, a JavaScript application with node modules directory, which tends to be quite big, it can become quite big, a lot of files, or maybe you have some data files that you're using as input, you can run into these kind of things. So one thing that I don't see very often is that there is a thing called a Docker ignore file. And this is pretty much the same that as you will see probably in any Git repository, a Git ignore file. So it's same syntax, and you can explicitly remove things that you don't want to be copied over. You can define things that you want, maybe the only things that you want to be allowed, and so on. And if I now do the same thing, but with my Docker ignore active, then it's not transferring files that are not allowed to be put into the context. So yeah, that's a pretty quick fix if you run into these kind of things for the context. And the other part that I wanted to touch is the cache. Whenever I run a build, you can see actually that some of the steps are cached, and those steps are, well, the ones define every command in Docker. And why is this relevant? Let's suppose that you're working with a Docker environment that you're using as a build environment. If the first thing that you have in the top of your file is copying your source code into Docker, and then do the build within Docker, every time that you touch your sources, it's going to invalidate the cache. So if I modify or add maybe here a different command, what's going to happen is that anything below this command is going to be invalidated. So now the only thing cached is the second command, and everything else needs to be run again. Because of the order, again, it matters what you do first. So what you want to do is to have a certain order that things that might be expensive in time, I don't know, maybe you want to install some dependencies. If you want to do something like, I don't know, apt update and install curl because you need it for something. You want to do this the very first thing instead of the last, because if you do it the last, whenever I change my sources, it's going to install again all the dependencies. So what you would want is do this the very first in your Docker file, and then you can still, yeah, this is going to be run the first time you build it, and it's going to be cached. And then the next times that you run your build is not gonna affect that anymore. So yeah, those are the things that I wanted to touch about in general about Docker. And the last part I wanted to touch is the specifics about Java. And basically, the very first thing to mention is, of course, the JDK base versus JRE. So your build environment versus your runtime environment. It's something that, again, is sometimes is overlooked. People just create a Docker file with JDK. Maybe they even build the application within Docker, but then they also use the JDK as the runtime environment. And what's the thing with that, you would ask? Well, they are quite different in size, and actually it has gotten better over time. But a couple years ago, for a while, it was pretty bad. And right now, for I don't know, version 17, which is the latest LTS, the runtime environment is 260 megabytes as a base. So that's the minimum amount that you are gonna need if you have a Java application. But if you just go ahead and use the JDK, it's gonna be almost half a gigabyte. Add to that, I don't know, Spring Boot, it's gonna be easy, another 100, 200 megabytes base. So for even very simple applications, you are gonna end up with 600, 700 megabytes of a base image. Is it that much of a big deal, 1 gigabyte nowadays? Maybe not, but every time that you pull an image, every time you push an image, you build it, yeah, you are, it's a little bit of a waste. So, of course, you could use multi-stage. You could build your application with JDK image, then copy the outcome, maybe a jar file, maybe a Word file, and then use the JRE. But there is one extra step that you can also do. Let's first remove this. There's an extra step that is that you can also build your own custom JRE. And this is all available or based on what it was introduced with Java 9, which was the concept of Java modules. And basically, the JDK was rewritten in a way that is modular. Only the parts that your application is gonna need from the Java runtime environment, you can create a custom version of only what you need, and it's gonna be smaller. You can remove also things that you don't need. So there are two tools that come from the JDK, which are JDeps and JLink. So JDeps, basically what it tells you is which modules is your application using. And I do have example. just to show you, it's a very simple hello world thing, which is just actually using the Java login dependency. And if I run the JDeps command, it tells me, well, okay, you're using Java-based module, and you are also using Java login. And based on that, then I can use I can use JLink to actually build a custom Java runtime that is going to include those two modules and nothing else. And if I build now this image, if you remember, the basic JRE is like 260. So so now with the custom JRE, it's like half. So I'm actually saving a lot of things that are not needed. And in this case, I'm just using a smaller on the smaller side of basic Linux Debian, but we could also go with Alpine, and it could be even smaller. So it could be actually, yeah, maybe around 60 megabytes or something like that. When you compare it to if we are just not careful and just rely on JDK for everything, you compare 60 megabytes to 400 megabytes. It's quite a difference. But yeah, this is of course not without its own things to be aware of. One thing is about Java modules. There are still a lot of libraries out there that if you rely on, they might not be fully compatible, or they might not be fully designed to be used as modules. So you can still use them, but you need to be careful about that. And of course, if you build a JRE which is custom and doesn't include everything that is needed by those libraries, you will end up with a class not found exception when running your application. So workaround, you can manually define dependencies. It's just actually very simple. You can add just here something like, I don't know, maybe you need you are doing a lot of reflection, and yeah, you need and support, and maybe you need the JDK unsupported module. Maybe you need something for the database. You can add things here. So that's one thing to be aware of. So JDeps is not always 100% accurate, but you have some control. And the other part, which I think is very relevant because Spring Boot is very spread, is that it's pretty common to use this Spring Boot fat jar that includes all dependencies bundled in a single jar. If you would have in a situation like that, the way to go is actually to unpackage first the fat jar and then run JDeps over all the jar files. But other than that, it's something that can save again quite some size. And I think I'm a little bit over time, but just a small remark about why we usually overlook this. Of course, storage is very cheap nowadays on the laptop, on the cloud, on the server. Maybe you don't worry that much about it, but yeah, it's if ever you run into issues and you get a DevOps guy telling you, hey, you are using too much space in your container registry, you know where to look into. Caching is everywhere. So I mentioned that, yes, having heavier image. Every time you push, you pull, you build it, you need to take it into account. But yeah, of course, you pull an image and then the image is there. If you have a build server which is pulling the image, is probably also caching it somewhere. Container registry is gonna be caching at some point, so it will mitigate a lot and hide the potential delays. Also, we kind of work with an environment that is traditionally tagged as being just slow. Java overall, Kubernetes, pipelines can get very slow as well. Is it gonna make it that much of a difference if it takes 10 seconds to pull an image when your pipeline takes 15 minutes to build? Probably not. And of course, even when deploying a new image, nowadays we have redundancy, we have deployments that take zero downtime. We don't notice, we just click a button, go for a coffee, come back 15 minutes later, oh, deployment is done. So yeah, I guess it is relatively easy to overlook these points that I talked about. But I think it's still something good to be aware about. And of course, whether you want to spend the time on it, it's gonna depend on each scenario. Maybe you have a constraint in your container registry size, and you have 20 microservices based on Java. Each microservice, every time you build it, it takes 1 gigabyte, and you are keeping a history of the last 5 builds. Yeah, it's gonna take a lot of space in the registry. If you have a constraint, yeah, you can look into potential solutions. If you have a constraint, because I don't know, your build process is taking too long, and you are using Docker as a building environment, yeah, maybe you have something inefficient in the Docker file. So yeah, it depends a little bit sometimes where you want to put those inefficiencies. But yeah, I think that's pretty much everything that I wanted to touch. I hope it was a bit interesting.